You're looking at a huge cloud of dust and gas about 70 million light-years away. What you're seeing is the Eagle Nebula, also known as M16, and it's one of many nebulae in our universe. But there are many other types of galaxies out there. You just need to know where to look. In today's video, we'll be discussing 5 of the most common types of galaxies you can find throughout the universe. And you won't believe some of them. They're so weird and bizarre. The first type of galaxy you can find is what we call a barred spiral galaxy. This type of galaxy has a central bar-shaped region of stars from which the rest of the galaxy extends. The name for this comes from the shape of the galaxy. The spiral part makes sense, but why do they have a bar? Well, the bar is actually used to help the galaxy get its arms around something. The center of almost all galaxies contains a supermassive black hole. We think there's even one at the center of our own Milky Way. These black holes don't stay still, however. As they have such strong gravity, they end up pulling in large amounts of matter around them, creating disks of hot gas. This disk of gas and dust is called an accretion disk. Now the problem is, these accretion disks don't form in one perfect circle. Instead, because of the different motions of the matter, they end up slightly misaligned with the equator of the black hole itself. This causes the disk to rub against the edge of the black hole's event horizon, and this creates tremendous friction. And because of the misalignment of the disk and the black hole, the friction doesn't occur in one spot, but instead in a ring around the black hole. When the accretion disk rubs against the horizon at these points, the gravitational potential energy of the system is converted into kinetic energy and is released as huge bursts of radiation. This happens all across the accretion disk, but since it occurs at different points at different times, this radiation is emitted at different frequencies. When combined, these emissions create a bright glow around the galaxy, which we call a broadline region. Some of the material in these regions will eventually make its way back out of the galaxy, causing it to glow even brighter. These are called outflows and can be seen in many galaxies throughout the universe. Broadline regions and outflows are found in both spiral and barred spiral galaxies, but tend to be more prominent in the latter. The next galaxy you can find is the elliptical galaxy. Elliptical galaxies are smooth, oval-shaped galaxies without any spiral arms. That may sound boring, but these can actually be extremely massive galaxies, containing hundreds or even thousands of times more stars than a spiral galaxy. The reason they appear so smooth is due to the fact that there isn't much gas present. This means fewer new stars are being formed. There are generally 2 types of elliptical galaxies. The first type contains mostly old stars. This is because it lacks the gas needed to create new stars. The second type, on the other hand, contains mostly young stars. This is because gas from nearby spiral galaxies gets pulled into these galaxies and forms new stars. But wait, it gets weirder. Have you ever heard of a cannibal galaxy? This is when a smaller galaxy gets its stars completely devoured by a larger galaxy. This then results in the smaller galaxy becoming an elliptical galaxy. The main difference between the 2 types of elliptical galaxies is the amount of heavy elements present. Elliptical galaxies with older stars contain less heavy elements, while those with younger stars contain more. This is because when the star is massive enough, when it dies, it releases these heavy elements into space. Then, when new stars are created, these elements are incorporated into them. Therefore, if the average age of a galaxy's stars is low, then there must be a lot of these heavy elements. On the other hand, if the average age of the stars is high, then there can't be many of these elements around. Next up is the dwarf galaxy. Dwarf galaxies come in 2 flavors, spherical and irregular. Both types are much smaller than normal galaxies. In fact, there are even smaller galaxies known as ultradwarf galaxies. These are so small, however, that astronomers debate whether they should even be classified as galaxies. For example, one such galaxy named Wolf-Rayet may only contain 2 million stars, which is roughly 1,000 times smaller than our own galaxy. The final type of galaxy you can find is the strangest and most terrifying, the active galaxy. Active galaxies are galaxies with very bright centers. This is caused by the supermassive black holes at their cores. However, unlike regular galaxies, active galaxies have enormous jets of energy shooting out from their poles. These jets are thought to be caused by the magnetic fields of the galaxy getting dragged along with the rotation of the accretion disk. Then, as they rotate, these magnetic fields get twisted together. Eventually, this pressure becomes so great that it causes a burst of energy to release from the magnetic field. This energy is released in the form of plasma, which is a mix of charged particles. These plasma jets extend thousands of light years from the galaxy, and in some cases, millions of light years. A special type of active galaxy is the quasar, or quasistellar radio source. These are the brightest of all active galaxies and can be found at the beginning of the universe. This is because they have the most powerful jets, which allow them to shine even through the fog of the early universe. It's believed that quasars were far more common in the early days of the universe. so finding them allows us to see back in time. So now you know some of the most common types of galaxies out there. But do you know how astronomers actually classify them? In 1959, astronomers came up with a new system for classifying galaxies, known as the Hubble sequence. This was a sequence which separated galaxies into 4 categories, ranging from purely spiral to purely elliptical. The system looked like this. However, over the years, it became apparent that there were problems with this classification. Firstly, not all galaxies fit neatly into one of these categories. Secondly, it didn't take into account the fact that galaxies evolve over billions of years. Finally, it didn't take into account the new information coming from telescopes. To fix this, in the 1980s, astronomers came up with a new system. This new system is shown here and is far more detailed. It separates galaxies into 3 main categories, ranging from spiral to elliptical. In each category, there are several subcategories. For example, spiral galaxies are broken down into A and B types. The difference between the two is the amount of dust present in the galaxy. SAW galaxies have a large central bulge with little dust and little in the way of spiral arms. SB galaxies have an intermediate bulge with an intermediate amount of spiral structure. SC galaxies have a small central bulge with lots of spiral structure. It works in a similar way for the other types of galaxies, too. If you want to learn more about the universe, check out our videos on exoplanets. Also, if you've enjoyed this video, let us know and we'll see you next time.